33. CPS Geometry. The Proof for Riemann Hypothesis, Part 2. In Part 1 of this video, we have found and demonstrated the answer to this question. Are there points in the CPS arrangement such that the distance between them is equal with the square root of any natural number? The answer is no. One can never find 2 points in the CPS arrangement such that the distance between them is equal with the numbers corresponding to the square root of the zeros of the CPS function. We have also shown, in previous videos, that there are numbers of identical CPS lines emanating from a CPS point. These CPS lines are characterized by the same underlying square root number. Next, let's investigate the number of identical CPS lines, corresponding to each square root number, and the geometrical patterns of their distribution. To accomplish this, we will take a slightly different approach. We will leave the cube octahedron for now, and we will concentrate our attention on the cube pattern in CPS. Early in this series we have presented, in some details, the cube in CPS. Now we will only consider the shells, or the outside layer of the CPS points, forming a cube pattern. More exactly, we are interested in the intersection of the fascicle of lines, starting from the CPS node located at the center of the cube, with the faces of the cube. By looking to the outside shell, 2 cube patterns can be identified in the CPS arrangement. 1. The CPS node, corresponding to the center of the cube, has a correspondent CPS node, located on the outside shell of each face of the cube, right at the center of each face. In other words, the axes of the 3D Cartesian coordinate system, with the origin in the center of the cube, intersect the center of each faces of the cube in CPS nodes. 2. The CPS node, corresponding to the center of the cube, does not have a correspondent CPS node, located on the outside shell of each face of the cube, right at the center of each face. In this case, the axes of the 3D Cartesian coordinate system do not intersect the center of each face of the cube in CPS nodes. The intersections happen between the nodes. For a better visualization of these cases, we will only show 3 faces of the cube. The other 3 faces are mirror images of the faces shown. Let's look at 2 layers of the outside shell of a cube in CPS. The 2 cases, identified above, can be seen clearly in this view. The outside layer is the shell corresponding to a cube of type 1. The inner layer is a shell corresponding to a cube of type 2. No other possibilities exist. We have shown already that the planes, with an underlying square lattice, have a periodicity equal with 2. Let's now create patterns corresponding to CPS points located at equal distances from the center of each face of a cube. Evidently, the distances from the center of the cube to all the CPS nodes corresponding to a given pattern are also equal. This observation confirms that all the CPS lines, from the center of the cube to all the nodes corresponding to a given pattern, are identical. They are all characterized by the same underlying square root number. To help you get a better understanding of the patterns that can be formed, I recommend you carefully observe next the evolution of these patterns. First, we present the patterns that can be formed on the faces of a cube of type 1. The patterns formed on the faces corresponding to a cube of type 2 are presented next. Finally, some 3D views of the CPS lines, corresponding to these patterns, are shown. For hands-on experience with these patterns, I highly recommend you visit our website and play with all the patterns available on the CPS viewer page. Looking into the distribution patterns of the CPS points on the faces of a cube, and the number of these points, one can see that there are in fact only three possibilities. A. 1 CPS point on each face. B. 4 CPS points on each face, and C. 8 CPS points on each face. We can now conclude that, for all possible patterns of CPS points, situated at the same distance from a central node, there are only three choices for the number of CPS points making up these patterns. These three numbers are A. 6 CPS points, B. 24 CPS points, or C. a maximum of 48 CPS points. Corresponding to these three cases, there are only three possible patterns of identical CPS lines. These patterns form fascicles of identical CPS lines with A. 3 identical CPS lines, B. 12 identical CPS lines, or C. 24 identical CPS lines. The remaining of this video shows such patterns of CPS lines. All these lines connect the center of the cube with patterns of nodes located on the faces of cubes, type 1 and type 2. You might wonder now, what is the connection between the facts stated in the last two videos and the Riemann hypothesis? In the next few videos, it is my intention to make this connection clear for anyone to see. To do that, we have to investigate the true nature of the connection between the arithmetic and geometry. More exactly, we have to investigate the current assumed correlation between the world of numbers and the space. We will discover big problems with the Cartesian plane and the Cartesian space. Next, it is imperative that we get to a common understanding of the Fourier series and Fourier's analysis. Remember, Riemann has shown how to use the zeros of the theta function to find the harmonics that can take the function that approximates the number of primes to the function that give the exact number of primes. Finally, all the pieces of the puzzles will be put together in a consistent and logical way. Only then, the beauty of this discovery will be ready for anyone to contemplate. Thus, be patient and enjoy the ride. Beauty makes beautiful thing beautiful.